Hello and welcome to Relatable Code. In this video, I want to show you the developer's safety net, or so we call it the try-catch block. So let's get started. So what is a try-catch block and why did I call it a safety net? Well, if we look back at the code that we wrote in the previous video, we see that we made some code for a calculator application. Okay, so the user inputs two numbers and an operator to perform some arithmetic operation. How this is done? First, we print a message for the user to enter a number. We get that number from the user's input. We prompt the user for another number. We get it here in this line of code. And we prompt the user for an operator, an arithmetic operator. We get that operator here in this input. And in this block of code, we're checking that operator. And based on that, we're performing the arithmetic operation. Okay. But one case you can look at, for example, is the division by zero, which doesn't really happen in math. Okay, so that will cause you some problems. What if I try to do it in my code? What will happen? Let's try to run our code and find out. So I ran my main function. Please enter the first number. Okay, let's enter 5. Enter the second number. That will be 0. Enter the operator, and now I want to divide. So if I try to divide, I get an exception. Okay, so as I said in the previous video, an exception is some sort of error in your code. And in this case, this exception happened because we saw a division by 0. That's the exceptions message. And the exceptions type is arithmetic exception. Okay, because it happened in the context of arithmetic operations. So that's the current problem. And we need to protect our user against this. We can't let our user experience problems like this, especially when the process is finished in this way. Because when you see process finished with exit code 1, it means that some error happened, okay? And something unexpected was taking place in your code, okay? So how can we handle this using a try-catch block? Well, you can do this. To write a try-catch block, first you have to write try, and at the end of try you can write catch. Okay, and open the curly braces for catch as well. And inside these two parentheses, you have to specify the exception that you're trying to catch. In my case, I just want to catch the normal exception, so I write something like E of type exception. Okay, and what I can do here, one way, is to select my code, cut it, and paste it in the try statement. Okay, that's one way you can do it. Later on, I will show you another way. So in the try block, I have my whole code. And in the catch block, I want to do something when I intercept an exception. What would I want to do here? Let's just print out the exceptions message. So we can do that by print line e dot message. Let's try to run our code again. Please enter the first number. Let's try 7. Second number 0. And an operator, we're going to use no, divide. And here you can see the exceptions message was printed out to the console. That's divide by 0. And also I want you to pay attention to something. Process finished with exit code 0 and not 1, which means that our program was successfully executed, but in our case, an exception was thrown. Okay, this is different from having exit code 1, which means if you're developing an application, that would mean a crash, okay, which is very bad user experience. So you would much rather have this than have the crash in that case. And we handled that in a way, we just copied our code into the try statement and we just catch the exception when it happened and printed out the message. But you can do a lot more than that. For example, you can print line e dot print stack trace, and I'll show you what that does. Let's run our function again. Enter the first number. That would be 6. Second number, 0. Operator divide. And here you can see the message first was printed out from print e.message. And then the print stack trace, I had a trace of that error from where it originated. So if I click on this blue line, I get navigated in my code to the line where this error occurred. And that's very handy to have in your code because it will save you a lot of time when you're trying to debug some issues that will happen with you, that might happen with you. Okay. So here, the blue line, the main.kt file, you will always look for the blue line in case of exceptions and errors. Okay, other lines may not be as important. When I clicked on it, I knew that the error happened with the divide operator, and the message was divide by 0. This gave me a pretty good idea of what happened and why it happened. Okay, which is why try-catch statements are really powerful tools and you absolutely need to have them in your arsenal. Okay. Now that was an example for a predefined error, if you want, in code. What if you want to define your own errors and try to catch those errors? You can absolutely do that as well. For example, here, after we intercept the first number from the user, we can make sure that this isn't a negative number. Okay, for some reason, you might want to validate that the first number shouldn't be negative. So what you would do here is, let's check if the first number is negative. So we need a condition, an if statement. If first number is less than 0, what would we do in this case? We would just throw an exception manually. And how we can do that with throw. And you need here to write a type of exception. And there are many types of exceptions in Kotlin and many other programming languages. Let's use a type of exception called illegal argument exception. Okay. And let's give that exception a message so that we know what's going on when we encounter this problem. So we open the parentheses and we write a string, which will be our message. And we say, first number can't be negative. Okay. Let's try to run our code again and enter a negative number, -3. As you can see, an exception was indeed thrown with the message that we specified for this exception and a print stack trace statement as well. This is a stack trace because it's something that you can trace to its origin, and in our case, an error. So if I click on the blue line, I get navigated to the line of code where this happened. I would inspect this line of code and I see that it's inside a condition, which means that this condition led to this exception. So our first number was indeed negative in this case. Okay, you can do even something and maybe print out that number if you want. You can do this. You can run the function again and write -6, for example. First number can't be negative, -6. That would also give you an upper hand in debugging when you want to know why this happened, not just that this happened. Okay? You might ask, why did we do this instead of just using a normal if-else statement and maybe just print this message to the terminal so that the user can know that this exception happened? Well, if you do that, you can't really have access to the very handy print stack trace function, which tells you where exactly in your code this exception happened. Okay? What if I want to handle my exceptions in different ways? So I want to handle my illegal argument exception in a certain way and my arithmetic exception in another way. I can definitely do that because here in the catch statement, I'm only checking for exception, which might be any exception. But in my case, I want to check, for example, for illegal argument exception, I can do something like this. So illegal argument exception, and catch arithmetic exception. And for example, in the arithmetic exception case, I might want to do something like maybe just print out the stack trace or just the message. Okay, so what would happen? Let me run my code and try to throw an illegal argument exception. So -7, I got the message and the stack trace, which is this. Okay, let's try again with 6, 0, and divide. In this case, as you can see, I just got the message because this was an arithmetic exception. Okay, so I didn't print the stack trace in here. What you can also do to achieve this, instead of writing two catch statements, you can write a single catch statement with the general exception, and when E is arithmetic exception or illegal argument exception. Okay, let's cut this statement, write it here. Let's cut this statement and write it here. We no longer need the second catch statement. And that's basically how you handle several exceptions in one place. Now you might ask, why did I use the is operator? Why didn't I just write arithmetic exception and illegal argument exception? Because if you hover over them, you can get classifier arithmetic exception does not have a companion object. Okay, which means that you're basically checking for a certain type that can be initialized in this way. So you want to check if E is of type arithmetic exception. That's different from checking if the operator has a value of plus or minus or times. Okay, you're checking for the type, not the value, which is why you need to add is before arithmetic exception and add is before illegal argument exception. Okay? What if you weren't able to catch your exception in your code, which could happen? So let's suppose instead of checking for arithmetic exception, we checked for something like unsupported operation exception. Okay, let's try to run our code. First number 7, second number 0, third number divide. As you can see, basically nothing happened. Not an error message, not a print stack trace, nothing. The process finished with exit code 0, which means our program didn't crash. But we didn't really take advantage of the try catch statement. So what you should do in every catch block and every when statement, as I told you in the previous video, just write an else statement like this. Okay. Specify what you want to do in that else statement. I may just want to write the error message. Let's try that again. Enter the first number, 6, second number 0, third operator, divide. And here you can see the message is now outputted to the window. Okay, so please watch out when you use the when statement. It's very powerful, but you have to think of every condition which might happen. And sometimes you don't know all the conditions which might take place, so you need an else block. Okay? What you can also do here, you can intercept this before it happens. So how can you do that? You can write if operator is equal to divide, okay, and second number was equal to 0. So here you would do something like also throw maybe an illegal argument exception, maybe an illegal state exception. I'm going to use the illegal argument exception. It's more suitable for this case. Because I don't want to see this message divide by 0. I want to see my own message. Okay, I may want to write user attempting to divide first number by 0, for example. Okay, which is more informative than that. And you can definitely do that. So let's try to run our program again. Illegal argument exception, which is this. I should see an error message and a print stack trace. So run it again. First number 0, second number, first number 3, second number 0. Operator divide. User is attempting to divide 3 by 0, which is more informative than the default exception that was being thrown. And that's what I want you to do in your production level code. If you want to intercept any sort of exception, make sure that you have details for everything related to this exception. Okay, I don't want you to throw exceptions in your production level code for something that's maybe trivial, but we'll get to that when the time comes. Okay, so let's say you're trying to make a smoothie. And for that smoothie, you need a banana, a strawberry, and some milk. Okay, and while preparing it, you peel the banana and you find out that it's rotten. So you want to do some action in this case. That's the try-catch block's power. Okay, so you can check for the exception, and it would be something like exception is rotten banana exception. So you may throw the banana, maybe continue without it, maybe get another one. And that's basically how you handle that case. Your milk may be old as well. In that case, you might get some other milk or you might try something else in that smoothie. Okay, so that's how you think of exceptions. And this is how you handle different exceptions in one place, which really provides a nice way to handle your code. Okay, because you're just looking at everything from a single perspective and you're trying to group everything, all the mistakes that can happen, in one place. And that's the true power of the try-catch statement. Okay? Now, before you find my content relatable, I want to warn you about something. Please don't use nested try-catch blocks in your code. And what I mean by that is try, catch, try, catch. Okay? That's really bad code. You just have this single try-catch statement. You can handle multiple exceptions in that try-catch statement, or at least try to divide your code as much as possible. We'll see how we can do that in later sections, but for now, please don't do that. Okay, and yes, I remembered something. I wanted to show you another way to use try-catch statements, or how to copy your code into try-catch statements. So for example, if this code were outside of this try-catch block, and I wanted to wrap it in a try-catch statement, how I can do that? I can select my whole code and write or type Control Alt plus T. I would get these suggestions. So I would go for try catch. Okay. And now if you see my code is wrapped in a try catch statement, and I just have to provide an implementation for the catch. Okay. And it's worth mentioning that as you have a try catch statement, you have a try catch finally statement. And let me show you what it does basically. This is the try block, this is the catch block, and this is the finally block. Okay. The finally block just contains some code that gets executed whether this try block succeeded or not. So whether our code successfully completed or whether an exception was thrown, the code inside the finally block will get executed. And how can we make use of that? Well, this provides us with a way to make sure that our code is executed, whether successfully or unsuccessfully. Okay, and that might be of use in the future. In addition, when you want to use some certain resources, like maybe some readers to, I don't know, parse some files, maybe you're trying to read from a certain file. I'm not going to open password. But maybe you have a certain reader in your code that's trying to process a file so that you can print out the information or work with it. You would then have to maybe reset that reader to its initial state or delete it altogether, because having it still functioning after it finished its job is not good practice. Okay, so that's how you use the finally block to clear your resources after you're done with them. Okay, let me just show you how this works in a very fast way before we end the video. So print line, code finished executing. Okay, I don't care if it's successful or not. I just want to print out this statement to indicate that my code finished. Let's try to run our function. Enter the first number. Let's enter 5. Let's enter the second number 2. Let's enter the plus operator. The result is 5 plus 2 equals 7, and code finished executing. Okay. Another example. Let's run it again. And this time, let's try to have it return an exception. So first number was 3, second number was 0, operator divide, and as you can see, code finished executing. Okay, as I've told you, this has certain use cases. You will definitely benefit from it. And that's it for the finally block. Okay. And now, if you find my content relatable and you really like these type of videos, please don't forget to leave a like and subscribe for future content, and I'll see you in the next video.